Hello guys, welcome back to Civil Engineering YouTube channel. Please subscribe our channel for daily civil engineering videos. Today our lecture is about the soil mechanics. In this lecture we are going to solve one numerical problem and to find out some unknown parameters for the soil sample. The problem states that if a soil sample has a dry unit weight of 18.5 kilonewton per cubic meter, moisture content of 10% and specific gravity of 2.65, then find out the void ratio for the soil sample, the moisture unit weight, the saturated unit weight for the soil sample, and the weight of water added to soil to reach 80% of the saturation. So we have to find out some 4 unknown parameters for this soil sample, which is a moisture unit weight of 10%, dry unit weight of 18.5 and specific gravity of 2.65. So the given data for this soil sample is that the dry unit weight is 18.5 kilonewton per cubic meter. The moisture content of the soil sample is 10%, and we can say 0.10 in decimal. If we divide this by 100, and has a specific gravity which is represented by Gs is 2.65 for this soil sample. So first we have to find out the void ratio. So void ratio is represented by small e. It is unknown to us. To find out the void ratio, we have to use some equation in order to find out the void ratio. So the one equation which is the given data in order to find out the void ratio is the dry unit weight is equal to the Gs into gamma W dividing by 1 plus E. Now in this equation we have Gs, specific gravity, we have gamma W. Gamma W is the unit weight of the water, and the unit weight of the water, it should be kept in mind, it is 9.81 kilonewton per cubic meter. Gamma D, which is the dry unit weight, is also known to us. So the only unknown is E. So that's why I use this equation in order to find out the void ratio. So 1 plus E, if I shift this value into this left side, so it will be 1 plus E equal to the Gs to gamma W dividing by gamma D. So now if we put the values, so 1 plus E is equal to Gs is 2.65 multiply with the gamma W, which is the unit weight of water, and it is a standard that gamma W is 9.81 dividing by gamma D, which is 18.5. So by solving this, we get 1 plus E equal to 1.40. Now E will equal to, E comes out to be 0.40. So the void ratio for this soil sample is 0.40. Now we have to find out the moisture unit weight. So the B will be moisture unit weight, gamma moisture. Now to find out the moisture unit weight, we can use this equation, that gamma moisture is equal to gamma dry into 1 plus water content. Now we know that the gamma dry is 18.5, water content is also given to us, which is 10%, so we can find out the gamma moisture for the soil sample. So gamma moisture will be equal to gamma dry is 18.5 into 1 plus water content, and water content is W, which is 0.10. So now by solving this, I got the value of 20.35 kilonewton per cubic meter. Now this was the way how to find out the gamma moisture or the moisture unit weight. Now the third one is how to find out the saturated unit weight. So saturated unit weight. So it can also be found by this way. Saturated unit weight is equal to gamma dry into 1 plus W. But now in this case, for the saturated case, we don't know about this water content, because before it was moisture unit weight. So in case of the moisture unit weight, we know that the moisture content present in the soil sample was 10%. So we plug this 10% here in order to find out the gamma moisture. But in case of saturated unit weight, we don't know about our water content. So first of all, we have to find out the water content for saturated soil. So for saturated soil, it means that the degree of saturation for this soil sample is 1 or 100%. It is 100% saturated, so then we have to find out the water content for this soil sample. So in this way, we will find out this. We will use this equation: is degree of saturation into wide ratio is equal to GS into water content. So by this equation, we can find out our water content, because degree of saturation is 1, wide ratio we know for the soil sample 40.40, GS is known to us for this soil sample, so we can, the only unknown which is water content, so we will easily find by this formula. So W will be equal to the S into E divided by GS. So S is 1 here, multiply with the E, the wide ratio is 0.40 divided by GS, GS is 2.65. So multiplying it with the 100%, because the water content is always expressed in 100% in percentage. So water content comes out to be, for a saturated soil, it comes out to be 15% by multiplying these values. So now we find out the water content for a saturated soil is 15%. So now we can put this value here in order to find out the gamma saturated. It will be now gamma dry into 1 plus W. Gamma dry is 18.5. It is known to us. 1 plus W, which is 15. 15% means that 0.15, because I used here in decimal. So by multiplying these values, I got 21.27 kilonewton per cubic meter. So this is the way how to find out the gamma saturated. Now the fourth part says that find out the weight of water added to the soil to reach 80% of the saturation. This case, gamma saturated was for the 100% saturation. Now we have to find out the weight of water that have saturation reaches up to the 80%. So we know that the gamma moisture we found out before, gamma moisture was 20.35 kilonewton per cubic meter. But we don't know the weight of water that to be added to reach 80% saturation. So it means that we have to find out first the gamma moisture that at 80% saturation. So we have to find this, and then we can find the weight of water that to be added in order to get 80% saturation. So this was known to us, and this gamma moisture at 80% saturation we have to find out. So to find out this, we have to use simple formula at 80% saturation equal to the gamma dry multiply with the 1 plus water content. But this water content, we use the same formula again, but in this case the water content is unknown to us because we are using 80% saturation. We are not using fully saturated soil. So water content, we will find out the water content now for the 80% saturation. So in this case, it will be again the same formula. This formula will be used. The water content 80% is equal to the S multiply E divided by GS. So saturation is 80% here. So the water content for the 80% saturation will be, the degree of saturation is 80%. So we will write it here 0.80 because it is in decimal. So I just divide this 80% by 100. So I got 0.80. So this is 0.80 multiplied with the wide ratio, which we found out before. It was 0.40. So it was 0.40 and G is a specific gravity for this soil sample is 2.65. So we found out that the water content is 12%. We will multiply this with the 100. So then we got 100% because water content is expressed in percentage. So we got 12% of the water content. Now we found out the water content at 80% saturation. So we will put in this formula So we will find gamma moisture at 80% saturation equal to the gamma D dry, which is 18.5, multiplying with 1 plus water content is 12%, or we can say 0.12. Now if we multiply this value, we get the moisture, gamma moisture for the 80% saturation, which comes out to be here 20.72 kilonewton per cubic meter. Now, what is the weight of water that added to soil to reach 80% saturation? It is very easy now. We just have to find out the weight of water to be added. So it will be the gamma moisture for the 80% minus gamma moisture, simple moisture. So gamma moisture 80% is 20.72 minus gamma moisture, which is simple, to 20.35, which we found out before, 20.35. So this comes out to be 0.37 kilonewton per cubic meter. So this is the weight of water that should be added in the unit of kilonewton per cubic meter in order to achieve 80% saturation in the soil sample. Hope you guys understand how to find the unknown parameter for the soil sample, and don't forget to subscribe our channel for daily civil engineering videos. Thank you for watching our video.